Hi everyone. Got better sound now, so should be a good crisp lesson. Here we go. All right, should be called PR Day 2 on our calendar, and we got fractional stuff. So dealing with rational expressions, I guess we call them, and you can go ahead and read this. I'm just going to emulate what these words say, how to approach these as we do each example. So this first one. Oh, this is the biggest mistake people make in the world. I'm going to be annoying too. Hey, does 6 over 5 reduce? And the answer, of course, is no. It can be turned into an improper fraction, 1 and 1/5. But no, what if I do this, though? What if I make this 5 plus 1? Isn't that 6, by the way? Yes. Divided by 5. Still the same as this. Oh, look. Now I can cancel these 5s. This is great. 1, 1. And then apparently 6 over 5 equals 2. Is that true or false? And the answer, of course, is false. What I'm emulating right here is one of the biggest mistakes students make, and I from here on out will call those a 6 over 5 equals 2 error. This is a 6 over 5 equals 2 error. Canceling that n to the third with that n squared and making this an n, and then proceeding from there. This is a binomial, much like I made 6a if you want to call it a binomial. You cannot mathematically cancel part of a binomial with another monomial up in the top. Hopefully you know what binomial means, two terms, monomial means one. So I must teach that because this is one of the biggest errors, and I from here on out will call that a 6 over 5 equals 2 error. And you will hear it a lot if you make those errors throughout the year. Errors. Oh boy, already got my screen, touching my screen. Hold on. All right, my hand hit the screen and it screwed up the thing there. So this is what we got to do. Got to do n to the third over. What you got to do is factor this, and it's a GCF factoring. So what's in common between these two? Boy, I hope we remember this from our. This is what I mean coming into CAT. You got to have your math skills ready to go so that we can use them. So this is n times n minus 2. Now what we can do is actually reduce this. The way we look at this is we know 3 over 6 reduces, right? But a way you can look at reducing is making 6 3 times 2. Now, when there's a times in between two factors, then you're free to cancel those. And that is actually literally how 6 over or 3 over 6 becomes 1 over 2. This is now a times here. So now I can cancel this with one of these and then end up with an n squared. So this is the simplified form of that beginning question. And I like putting binomials. You notice I did this just by default by saying, without saying it, I mean, I like putting them in parentheses so that you understand that those, it has to be a unit and parts of it cannot be canceled. Here we go. 6 over 5 equals 2 error. Oh, this is great. This is great. This is wrong, wrong, and wrong. You cannot cancel a part of this is a quadrinomial. I guess it's a four-term polynomial. And this is a binomial. You can't take those parts and do that like that. But what you got to do is factor this. Now, we did teach factoring in a previous lesson. When you have four terms, by the way, you should make this plus a negative. This is grouping, factoring by grouping. What you do is you group the first two terms. This is why you make this plus a negative, because you got to group the minus sign or group that plus negative, that negative on the 3 for the second two terms. Pull out a GCF between the grouped terms. Plus, this is why this has to be plus a negative, because now you could take a negative 3 out. The key is in grouping factoring that these two parentheses are exactly the same. If they're not, then factoring by grouping just doesn't work. All right, so we got to make sure we do that. Now I'm going to write the bottom and I'm going to go ahead and factor. This is just a binomial that has a y squared GCF. Now don't get nuts. This is what drives me crazy. Should actually do one more step in factoring. I will still get someone that does this. That is a 6 over 5 equals 2 error. You cannot do that. What you got to do is complete the factoring by grouping thing by pulling out what I like to call a GCF y plus 2. This gets to be pulled out in front, just like I took a y squared out of the bottom and pulled that out and undistributed. Factoring is like unfoiling or undistributing. Sorry if I use the foil word and a teacher hasn't used that before, but that's what it is. And then what you're left with is y squared minus 3. And then on the bottom you have y squared and that y plus 2. Now you have free multiplied factors that can be canceled now. And then you're left with the final answer. Don't go this far and make yet another 6 over 5 equals 2 error. Wrong. Okay, that is the final answer. Those y squareds do not cancel. All right, want to move on. Don't want to talk too long on all of this. Okay, now we just have a couple fractions multiplied together. No. No. Again, 6 over 5 equals 2 errors. Okay. The only way these two would cancel if they're both identical. They're not. Ooh, that's tricky. These are close. But really what these are, we'll look at like this, numbers. What's 3 minus 2? 1. What's 2 minus 3? -1. What are these two things called compared to each other? Opposites. So these are actually opposites of each other. If you're thinking about dividing these two, 1 divided by -1 is -1. Oh, I love taking algebra and then thinking about numbers with it because all variables are replacement for numbers. They're mysterious numbers that we don't know, but they follow the rule of numbers. And then this one is what I like to call a difference of two squares. Boy, I hope you got your factoring down. So what I'm going to do is make this one big fraction. And I'm going to put all the factors up on the top and all the factors on the bottom. But what I'm going to do about this is show that this is almost identical to this, but it's the opposite of this. So what I'm going to do is pull out a -1, like a GCF, and it's just sitting there in the middle. 1 divided by -1 is -1. -n divided by -1 is n. So this becomes n minus 1. So that's how I turn that into this. And then I'm going to factor that difference of two squares in a nice, neat fashion here. Remember, as I'm doing this, take your 5-minute breaks for chunking. Okay, let's see where we're at there. We're at 7, so you should have taken a break before the last example. Now that these are multiplied all the way across, I can cross-cancel any factors that are exactly the same. Boom, 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 boom. And then I end up with a -1 over n minus 3. And that's the final answer. Hopefully I haven't made a mistake. Double checking. Yes. The n plus 3's cancel, the n minus 1's. All right, let's move on. Oh, baby, I love these. Okay, going to do the same thing, but when you see division, you, what's the rule from grade school? Lexi Samuelos, my 10-year-old, knows what to do with dividing fractions. And what she knows is it means multiply the reciprocal of the second one. So this flips. The first one, well, I got a binomial here. So again, don't be doing the 6 over 5 equals 2 error. Factor, and that's factoring out a y, GCF, y minus 3. And guys, we really got to get good with factoring, understanding that it's the opposite of distribution. If I go ahead and distribute this back, I end up with what I started with. All right, so I know I'm going kind of fast, but we do have a lot of times where you can ask questions. So you got a lot of options in order to get this figured out throughout the year. So that's why we're doing these notes like we are. Every single day you can meet us from 2 to 3 for just making sure we're on the right page. All right, now we start doing a canceling thing. I may choose colors. So this random y that's been pulled out can be canceled with this random y. This is weird. Other than that, with this being flipped, this isn't flipped, and I pulled out a y for the GCF. I think that's it, because 3 doesn't go into 14, 3 doesn't go into 2. I'm wrong. I could take out another y. I'm going to do this. Make that y to the first, because this is y squared over y. One y cancels, so I have a y left over. So I did miss one other one possibility. It's okay. I would have caught it if I tried to write the final answer. I'm going to write the 3 first, multiply by that leftover y, because y squared over y, only one of them cancel. y minus 3 in parentheses blocked. Can't be canceled with a y on the bottom, even though they're all gone. Then I have a 2 and a 14 on the bottom. I'm going to go ahead and multiply those because this just doesn't cancel with the 3. And an n. All right. That's the simplified final answer of this scenario. So I want to make sure I read my directions if there was anything else. No, just basically simplify. Okay, we're not doing these, but if you wanted to ask me in a 2 to 3 and no one else is asking questions, we can show you how to do that one. All right, and then a division question. We're at 10 minutes. Hopefully I'm done by 15. We'll see if that makes that happen. And again, take 3 breaks, I guess is the best way to say this. I'm going to go ahead and understand that this is flip, but then I'm going to go ahead and do each factoring scenario. So this goes up on the top, this goes on the bottom. But let me get this first one factored. This is a classic, I like to call it an MA. I don't know what your teachers did last year when this is 1y squared. Then all you have to do is figure out in this trinomial what multiplies to 10, same two numbers, add the negative 7. And I'll show you how this works as far as undistribution. First of all, it'd have to be y and y here because y times y is y squared. I'm emulating how this is the reverse of multiplying polynomials. That's what factoring is. Now, what kind of numbers multiply to a positive and add to a negative? No time. We got to figure this out. It's a negative and a negative. And the numbers that multiply to 10, 2 and 5, but also add to negative 7 are negative 2 and negative 5. Now watch. Y times y is y squared. I did this all last year. Some reason students could not figure out factoring some of them, and you're just going to have to get on board here and do it. But every year I lament students not being able to pick this up. Just really focus on this. Then I would take this y times negative. That's negative 2y. Then this is negative 5y. That's negative 7y when you add that. Negative 5 times negative 2 is positive 10. This is checking that your factoring works, and it does. If when I multiply this, I get this answer, then when I factor, that is the correct factorization of that. Okay? Take out a 4y. Like I say, ask me questions when we have those times for office hours. That's a GCF factoring. Now this one's a little bit tougher. I'm going to do this 2 ways. One way is just guess and check. Many people are going to be good factors because they're numerate. They're very good with numbers. This times this has to equal 3y squared. That's what factoring is. That's what your final answer has to emulate. Even if you do a trick, the only way you could get 3y squared is if it's 3y and 1y. This is one thing about checking your answer when you're done. So many people do a trick and then put y and y there as their final answer. This doesn't even multiply to be 3y squared. It doesn't make any sense at all. All right, and then I'm going to guess. Now, these two numbers have to multiply to be negative 8. So what would be my possibilities? Negative 1 and 8, negative 8 and 1, 2 and 4, one of them being negative. I can already figure out that I'm going to take this times this. And I get a negative 2y at the end. So I'm going to put minus 2 here. That gives me negative 6y. And plus 4 here. I'm focusing on two numbers that multiply to be negative 8. This becomes positive 4y. Negative 6y plus 4y is negative 2y. Negative 4 or negative 2 times 4 is negative 8. And of course, 3y times y is 3y squared. So that is the correct factorization. I'm taking a lot of time on this one, and that's okay. Lost my 4 there. The other way you may have learned is you take 3 times negative 8 and you get negative 24. And then you got to find out what two numbers multiply to negative 24 and add still to negative 2. And the answer to that is 4 times negative 6. Wait a minute, those are different numbers. It's because what you're supposed to do next is different. You're supposed to take the 3y squared and take that middle term and split them up into those two magic numbers. Now this is kind of a trick, I like to say. Little trick when the leading coefficient is not 1 like this one, it's 3. Now I don't know, in years past, Lockport made a decision that this was the way to do it. You do it any way you want. Sometimes teachers teach different ways, and it's okay. I like this. If you were in honors, it would just be guess and check. That's what it always was. No tricks. Understand that I like to use the word FOIL, understand you're undistributing. Your answer must multiply to be the question. So just get it to work. But anyway, I'm going to continue. I did a grouping after this. If you don't want to listen to any of this, if this is not what your teacher taught in the past, don't do it. Don't do it. Again, it's hard. Then this one you take out a 4. Again, like I said in the previous, the only way this works is if these are exactly identical. Then you pull out a y minus 2 and you're left with a 3y plus 4. So you see that over there. Okay, so 2 different ways of approaching that factoring. Again, don't forget it was a division. That's why this flipped. To divide, you multiply and flip. Now it gets a little crazy. Let's take care of the binomials that are exactly correct or the same. Boom, boom. Y minus 5. Y minus 5. Great. Remember, I can't take that. This is stuck because it's a binomial. But what we could do is cancel. Let me do it a different way. Cancel all the way this out and leave a y up there. And then 4 goes into 32 8 times because these are 2 free numbers as factors. When I look up at the top, all I have is an 8y. Be very careful on this canceling and not losing stuff. These completely cancel to be 1s, and this is all that's left on the bottom. Remember, 6 over 5 equals 2. 6 over 5 equals 2. You cannot cancel parts of a binomial with other parts. So this is the final answer. All right. Okay, last but not least, adding and subtracting fractions. Let's remember how you add a fraction real quick. 1/2 plus 1/5. The only way you could add these, let's say 1/2, 1 over 2y and 1 over 5x. Let's get it to be like a algebra question. Well, the way you add fractions is you get a common denominator. So what's the common denominator between 2 and 5? Quick answer is 10. It's the only thing that the common multiple that 2 and 5 both go into. And then this one has a y and this one has an x. So they both need an x and a y. So what is this fraction missing? It's missing a 5 and an x. And you must multiply top and bottom by that. This one's missing a 2 and a y. So this one needs to be multiplied top and bottom 2y. Then the final answer in this one is 5x plus 2y. Nothing you can do with that. They are not like terms. Over the common denominator, which is 5 times 2, 10, xy. 5 times 2 is 10, xy. But remember with common denominators, you write it as one common denominator, just like this. 1/2 plus 1/2. 1 plus 1, 2 halves, which actually equals 1. And let's think about that. What's half a pizza and another half a pizza? Ooh, I'm hungry. 1 whole pizza. 1. Okay, so that's why we carry the common denominator. Trying to go fast here. Like I said, we have office hours if this is too fast. So, n minus 1, is that the same as n minus 5? No, they're completely different. So what's the common denominator? N minus 1, n minus 5. What's this one missing? N minus 5. So you multiply top and bottom. And by the way, this should be review. You should have done something like this in Math 2 or Math 3. So that's what CAT is at the beginning. We're doing all these review concepts and smashing them all together to see where you're at here. And then after we get into chapter 1, it'll get a little bit better. But we're really going to test you here early. Distribute up in the top. Do not distribute on the bottom. As a matter of fact, I'll show you what you should do on this. Plus 4n minus 4. Remember what I said, the whole point of doing the common denominator is to put the numerator under or over that common denominator. So this denominator is n minus 5, n minus 1. This denominator is n minus 5, n minus 1. When you add the numerators, you put them over that common denominator, n minus 5, n minus 1. And do not factor or FOIL those or multiply those. All right, add the middle term, and I get n squared, sorry I changed to red, minus n minus 4. You should check, is the numerator factorable? And the answer is it's not. I could do that in a flash because there are no two numbers that multiply to negative 4, 1n squared, 1n squared, and add to be -1, okay? And that was from your factoring examples from before. Then last but not least, I'm gonna go do this one fast. Like I say, I wanted to keep this under 20 minutes and it's already a fail. All right, first thing you gotta do is factor these. So this is n times n minus 2, 2 over. This is 1 over n, and I'm gonna leave a lot of space, minus 3 over, and then factor that as a difference of 2 squares. Hopefully that happened in the factoring notes, but hey, how do I know this is the right answer? N times n, n squared. Positive 2n, negative 2n. Gone, they cancel. Negative 2 times 2, negative 4. That's what factoring is. It's a reverse of multiplying, but making sure your answer actually multiplies to be the question. Now, what is the least common denominator? I have an n, don't have an n. Guess what? This is missing an n. This one has an n minus 2. This one doesn't have an n minus 2. This is the way you can do this. Oh, I made a huge mistake, though. I'm going to multiply top and bottom by the same thing. Okay? Because that's a form of 1. So when I'm doing a common denominator, I must make sure everything, I multiply both top and bottom of each fraction by what's missing so that it's multiplied by a form of 1. Blah, 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 blah. And then, oh, this one has an n plus 2, but this one does not. Oh, for the love of dog. I don't know what's going on. Okay, let's try this again. This is great in the video. N plus, I think things moved. Let me pause. Good. My hand touching the screen moved my notes. N plus 2, N plus 2. And then I'm sorry that this one is also missing an n plus 2. By the way, don't forget that n plus 2 times n minus 2 is n minus 4 squared. So up on the top, you're going to distribute 2n plus 4. What did I just say this was? N minus 2 times n plus 2 is n squared minus 4. And then minus, you should have made this plus a negative in case this was a binomial, because then the negative would have to be distributed, but it doesn't. And then what are we going to do? Put it all over that gargantuan common denominator. It's the whole point of adding fractions. All right, then you add, and I hope to goodness this isn't factorable at the end, n squared. I like canceling these out when I really shouldn't cross it off, but I don't want to look at it anymore. I get confused. Negative 3n plus 2n is negative n. And then negative 4 and 4 actually do cancel. So I think I'm good, but I'm not. I was just going to say I hope this doesn't cancel at the end, and it actually does. Because the numerator has a GCF. I'm going to pull that GCF out, and then what this becomes, when I pull out an n, this becomes n, of course. What's n divided by n? 1. All right, and then these n's are going to cancel at the end. And I'm going to circle this answer because I didn't want to go this long, but boom, and there you go. All right, like I said, office hours if this was too fast.